Hello, this is Mr. Stansbury. I'm going to take you through the special number sets notes. Okay. At the end of this, you should be able to say, I can recognize and classify numbers by their number sets. Okay, so let's talk about all the number sets. Okay, there's n, which are the natural numbers, 0, 1, 2, 3, 4, on to infinity, counting just like the counting numbers there. Z are the integers, from negative infinity, negative 3, negative 2, negative 1, 0, 1, 2, 3, all the way up to infinity. Z plus, with a little plus up there, is the positive integers, 1, 2, 3, 4, so forth and so on. Q are the rational numbers. Excuse me. Those are numbers that can be written as P over Q. So it can be written as a fraction, where P and Q are integers, and since you cannot divide by 0, Q cannot equal 0. So as long as you're writing one integer over the top of another integer, some kind of fraction there, that is a rational number. So like negative 1/2, 4/3, 2 could be written as 2 over 1, and 0 could be written as 0 over 1 as well. So those are all considered rational numbers. Irrational numbers are numbers that cannot be written as P over Q, which also irrational numbers cannot, the decimal never ends and it never repeats. That's one way to figure out an irrational number. So let's add that on as well. Okay, so I added that on as well. Their decimal never ends or repeats. Okay, and then real numbers are all numbers that can be placed on a number line. Pretty much about the only things that are not real numbers that we have dealt with so far in math are the imaginary numbers. Okay, so those are all the different types of number sets. Okay, so with that, what we're going to do is we're going to complete this table here. Okay, so we're going to fill this in. So n, remember, is, let's go back to that, just look really quick. Natural numbers starting at 0, going on. Z, integers. Q, rational numbers. Q prime is also considered the irrational numbers. And then, and then R is the real numbers. Okay, so let's look at that. So n is starting at 0. Here, let's write that so you can see that a little better. I'm just going to kind of write little notes up here so I can remember. 0, 1, 2, 3, ... Integers is ... negative 1, 0, 1, ... all those, right? Q is the rational numbers. That's P over Q. Anything that you can write as a fraction. Q prime is the irrational numbers, right? That's the non-ending or repeating numbers. And then R is the real numbers. Those are all the numbers that we know of so far. So, minus the imaginary numbers. Negative 4 does not fit into the natural numbers. It is an integer, so check it fits in there. You can express it as a fraction. It could be negative 4 over 1, so that works. It is not, it ends, it's not a number that goes on forever and ever, and it is ending, and it doesn't repeat because it ends. Okay, and then yes, it is a real number. 3 divided by 7 is not a natural number because it has to be one of these counting type numbers here. It's not, oh, that's what I should not be doing, putting the check there. So it's not a natural number. It's not an integer. Okay, but it is expressed as a fraction. It's showing it right there. Non-ending or repeating. And also remember, this cannot be expressed as P over Q. And since it can be expressed as P over Q, we know that it can't be Q prime, right? So these two columns here have to be exact opposite of each other with check marks. And then 3/7 is a real number. Okay, square root of 6 does not, when you put that in the calculator, does not give you a nice integer number here. If that was square root of 9, that would be fine, but it's not. So it's not a natural number. It's not an integer because it doesn't give you a nice number. P over Q cannot, that square root cannot be expressed as a fraction. And so this one does actually goes on forever and ever, and it does not repeat. So a lot of irrational numbers are going to be the q prime here, right? So that would be irrational, and it is a real number because it's not imaginary, so we're good to go. Okay, 2.7. It's not a natural number. It's not an integer, but it could be expressed as a fraction because we could write that as, say, 27 over 10. So that is a fraction, which means it's not a non-ending or not repeating number. It is also a real number. 2.7 repeating, still not a natural number, still not an integer, but you can still express that as a fraction. And we will go over that in a later section as to how to show that as a fraction, same with 2.7. So, but you can express that as a fraction. So that means it's not in the q prime, but it is a real number. Square root of 25 equals 5 when you go through and simplify that. So that makes it an integer, a natural number and an integer and something you can express as a fraction because you could put that as 5 over 1. So therefore it's not a q prime, but it is also a real number. Pi, not a natural number, not an integer. You cannot express it as a fraction. It is not never ending or repeating number, so it's irrational, but it is also a real number. Square root of negative 11. Cannot take the square root of a negative number, so that's, remember, our imaginary numbers, not a natural number, not an integer. It is not, you cannot express it as a fraction. So it's not only is it not rational, but it's not irrational, which I know sounds strange, but so earlier when I said if it's not in q, it's got to be in the q prime. This is actually an example where it's not, because this irrational number has to be a real number, and this square root of negative 11 is not a real number, so this is actually not any of these here. So this is the imaginary number. Square root negative, the opposite of the square root of 11, is a real number. So this one is okay. Oops, nice check mark. Try that again. There we go. It's not going to work out to be a nice number, so it's not a natural number, and it's also negative. It's not an integer. We cannot express that as a fraction, but it is a never-ending or repeating decimal. So that would be irrational or q prime, and again, it is real as well. Okay. One last thing to look at here is this here. Determine whether each statement is true or false. Are all of the integers a subset of the natural numbers? So all we have to do is come up with one integer that's not a natural number, and that would show it that it's false. Okay, so what this should also put on there is it should say if false, give a counter example. That's a really nice way to do this, so let's do that. Oops, not equals, but this is false, and our reason why, our counter example, is like an integer that's not a natural number is like, say, -1 is an integer that's not a natural number. Okay, are all the rational numbers a subset of the real numbers? They all are. Every rational number is also real. Okay, are all the real numbers a subset of the rational numbers? No, there's some real numbers that are irrational, so that would be false. Right, and then we can come up with any sort of thing like, say, square root of 7, pi, so forth and so on would be our examples, counter examples. Okay, are all the positive integers, how about this, the positive integers, does that equal the natural numbers? Yes, except for 0. 0 is not a positive integer, but it is a natural number, so this would officially be false, and our only counter example we have for that is 0. Okay. The positive integers, if we take the positive integers and we have the union of those with the negative integers and the positive integers, does that equal all the integers? True, except for 0 again, because 0 is not a negative integer or a positive integer, so this is officially false, and our reason why is because of 0. Okay, And then the rational numbers union the irrational numbers, does that equal the real numbers? Yes, it does. That's everything that all the real numbers are either rational or irrational. Okay, that is all there is for special number sets. If you have any further questions, please feel free to ask in class. Thanks.